Started this series of discussions with a travel graph problem. Now, let us take up another example of the same concept. So, what is given here is a long distance train. The driver of the train observes that he has reached a certain spot which we have marked in our diagram as C. So he discovers or realizes that he has reached that spot 2 hours late. So to cover the lost time and distance, he accelerates from spot C. He accelerates to a higher than the normal velocity, normal speed, and maintains that higher velocity till the end of the journey to reach the destination. Destination is B, on time. So that is the data. Acceleration and then uniform velocity for some remaining distance. So the distance of the spot C from the destination is the is what is required in the problem. That is, from where he started the acceleration, how much is the destination point. So that distance we have to work out. Now, you can see in the graph, up to C it is a straight line, constant velocity. At C, a sudden variation occurs due to acceleration and then uniform velocity. In that graph, you can see a shaded portion. That shaded portion represents the extra distance covered during the acceleration and uniform velocity, higher uniform velocity. So that shaded portion distance is also equal to the time lost due to certain reasons, track repair, etc. The lost time is 2 hours. In that 2 hours, the distance covered is 2 into 80. 80 is the normal velocity given. 2 into 80, 160 kilometers, which is also represented by that shaded area in the diagram. So we are using the equation for the time of uniform journey as t. Symbol t is used. The time of uniform journey with 100 km per hour is marked as t. So to get that t, we are making use of the area of the shaded portion to the distance lost. So that shaded portion part is covering the lost distance. So on that basis, we are working out t. The other t is the uniform velocity time. The other time is the acceleration time, which is easily available because that is t equal to v minus u by a, acceleration. That formula gives. Now, once the t is worked out, the area above the line BC is what we require. CB, we have marked as CB. Area above the line CB is what we require. For area symbols, area formulas, simple geometrical figures only involved, triangle, rectangle or trapezium. So using any of this, any of the formula, you can get the area above the line CB, which is the required answer, which we have worked out as 840 kilometers. Now, after getting this answer, you can also verify one other point, that is, to cover this 840 kilometers under the normal speed, you would have taken 840 by 80 equal to 10.5 hours. Whereas in the acceleration and the higher speed concept, we are getting the time as t plus 1, that is 7.5 plus 1, 8.5 hours. The difference is 2 hours, and it is that difference is the time lost also in the first part. So it is so that verifies that the higher speed has helped for the journey to be covered exactly at the required time. So it reaches the destination at the correct time. So I think the rest is clear if you go through the solutions. Thank you.